Hey everybody, so welcome to part 1 of Become a Data Scientist, and believe me, I seriously mean it, by the end of this series, you will have all the tools necessary to become a data scientist. People post these 100-hour courses, which are great. I'm sure you would learn a lot in those 100 hours, but I'm going to show you in 3 hours, just 3 hours of your time, how to become a data scientist, what people actually do on the job, and I know what they do on the job because I've had several internships. I'm in my final year of university, and this is what you do day to day, okay? So step 1, you need to learn SQL, okay? I actually learned it from a databases course in school as well as on the job, but you don't have to do that. I'm going to teach you almost all of what you actually need to know in this first video, which is going to be around an hour long. Okay, so an hour of your time to get SQL. That is it. Okay, and not just SQL, also the relational design. Okay, what SQL is actually doing is pulling data from these relational databases. That's, in general, that's what you would expect when you go to a workplace. Some people are using slightly more modern techniques that have their advantages and disadvantages, but seriously, still in the market today, almost everywhere you go, you will see that you have to use SQL queries to get your data, and that is not a punishment. It's great. It's still awesome, even though it's been around for so long. So, in this lecture, I'm going to show you all you need to know about it, about the relational design, and that really the relational design is just we put data in tables, and the tables, the information that we put in those tables is related to each other. That's basically it. So we're first going to go over the relational design, and then after that we'll talk about actual SQL queries. I know I'm writing this by hand, but I'm doing that on purpose to show you that it's very simple. Okay, it'll take a little bit of memorizing some stuff, but not too much, and you can write it out by hand because they're often the queries that you make are very small, and if they are bigger, it's really just the same type of thing, but with more columns, more tables, and so on. Okay, with that being said, I'm really excited to get started. Let's get on our journey of SQL and the relational design. All right, so SQL / relational design. And if either of those sound scary, they really shouldn't. I'm going to explain both of them either way. Okay, so firstly, we're going to talk about this guy in blue. We're going to talk about the relational design, which means we put data in tables, and the data that we put in tables is related to each other. So if we have information in one table, then often some of the information in that table will be related to the information in other tables. Firstly, let's look at one table. Okay, so in a database, and so in this database, we would have multiple tables. Here's one. So in green, I have this table, which I am going to call customer. Okay, and guess what kind of information it's going to hold? It's going to hold only information about customers. Okay, so this is just saying this is the title, and then I'm going to give the columns of this table, which are, say, ID. That's a very important field that oftentimes you really just need an ID field. Okay, and we'll also hold information like first name. Okay, and for now, that's actually all we're going to have in this table. We're going to have an ID, and we're going to have a first name. Actually, let's put in a last name for fun. Okay, and a last name. Okay, and so what I showed you about a table so far is that it has a name, and that's going to characterize what's in the table. Obviously, we have customer table. It's about customers. Now, we have columns and rows in this table. Okay, so one column is the ID field, another column is the first name, the last column is the last name. And so every time we put an entry into this table, or a row, it's going to have those fields or columns, fields, columns, interchangeable. And so I would probably start the ID field at the value of 1. Actually, a lot of companies use these really huge numbers, which aren't actually necessary. We're going to put in the value of, say, 1, and first name, it's going to be my name, and it'll also be my last name. Okay, so I'm in the customer table now. And note how you would do this. You might do it in SQL, or you might just have it already. I'm just showing you a table that already exists, and I'm building it up from scratch. Okay, so just pretend that all of this data was already here, this table was already here, and I'm just kind of one by one showing you what's actually in the table. Okay, just to not be confused with if you're doing what's called a SQL or SQL insert, which would actually put this row in. We're not doing any of that. I'm just showing you the data. So maybe we have another ID field where we have my cat. Okay, his name is Willie. I hope not to misspell him. And he'd probably have the same last name as me. And maybe we have some rando, like John Spark. Okay. John Spark, if you're watching this, that's funny. Okay, so here's one table in the database. It's called customer. It has information about the customers in the database. So let's say that this database is actually for a store. It's representing some store. So we have 3 columns in ID field, a first name and a last name, and we have 3 entries or 3 different rows of customers. So we have one customer which has the name Greg Hogg, another customer which has the name Willie Hogg, and a third customer which has the name John Spark. Now, if it sounds like I'm beating this to death, that's because, I mean, this is, although be it simple, this is absolutely huge to understand that we have just columns of information, and then each row is some entry in the table, each characterized by what's called a primary key. Okay, so note we could have had information like this. Since we're making databases or tables off of real life information, people come into the world and we put them into our database, that we interact with them, we put them in the table. There's no restriction that we couldn't have 2 different people named John Spark. And this is why we need a primary key field, which is to uniquely identify a row. We need this ID field. This is going to be what's called our primary key. I'm going to put that in red. It's an important term. Okay. This is our primary key for the table. It uniquely identifies a row. Note that we will never have 2 entries in the table that have the same primary key. And if for some reason we did have 2 rows with the same primary key, well, then they're referring to the same thing. So maybe for some reason we had the ID of 4 here. Well, we probably shouldn't have this because it's gotta be duplicate data. So we have some column or set of columns that are unique per row. And that means that you will never find multiple rows with the same primary key. Or in our example, you'll never have multiple rows with the same ID field. That is the point. We want to uniquely identify a row. And so we don't have this. You would never see this. And so the easiest way to do this, if you actually go to any workplace, almost all of the time, you're just going to have an ID field, and then sometimes you might have something like an ID field and a date as your primary key. So you can have a primary key as multiple columns, though that 2-column combination could actually uniquely identify a row. But in our example, we're going to stick with what's extremely common and just have an ID field. Okay, so let's take a quick break from the relational design and just have a little bit of fun with SQL. Okay, so I'm going to write some queries in blue to pull some interesting information out of this table. So when we want to pull information, which in this course, I'm talking about how to become a data scientist. The only keyword you will ever use at the beginning is select. Okay, we want to pull data. Unless you are some sort of back-end programmer or doing something really wonky, you don't want to put information in the table. You don't want to change the information in the table. You do not want to delete any tables or take any information out of the tables. You have the database. They say, hey, use SQL to get whatever you want. Don't mess with it, okay? Even if you think it's bad design, maybe you can suggest that later, but don't mess with it. We're going to write everything with select, and its job is to pull specific data from the database. And right now we only have one table, so we're gonna pull specific data from this table. Now keep in mind that this view over here, okay, this is what the table looks like internally. As a user, you're actually not gonna see this. You're just gonna see this customer table probably, and then maybe there's some tricks you can use to look at a couple things quickly. But for now, to actually see this whole result, see everything here, to view this, you would write select star from what table? From customer. That's all we have right now. Okay, so if you wrote select star from customer, that would show you this table and probably more rows, because I would assume there's more rows in the table, but for now we're going to pretend that's it. All right, so to break this down, select, its job was to pull information. Okay, we said, what do you want to do? Just take information. So select. Okay, select what columns. What columns do you want to see? Star basically says all of the columns. So star is basically just saying select ID, select first name, and select last name. All right, so I'll get all the columns. And then from what table do you want this from? Well, I want it from customer. Pretty much the final question. What rows do we want? Well, this was the end of our query. We wrote select star from customer, and so I guess we want all of them. That's what SQL is going to assume in this case. We made no restriction on what rows we want to see, and so we're going to see all of the rows. Okay, so this is the first query that everyone will run, and then maybe they might actually limit the number of rows so it doesn't take quite as long or doesn't show you quite as much. But they're going to write a select star from the table and group of tables that you're interested in. All right, now to do something slightly more interesting, let's actually look at the rows. Okay, look at specific rows, I mean. So we want to do some filter where we don't see some rows, or equivalently do see some rows. Now to do that, well, it's actually very similar. We can keep most of our query, but I'm going to add some where clause. So I select star from customer, where, okay, where is saying, what rows do I want to see? Where, for example, where the ID, and capitals doesn't matter, it's not case sensitive. So we're going to select all the columns, or star from customer, where the ID is actually equal to 2. Okay, and now that we've limited the rows we see, we actually only see my cat, which is ID 2, first name Willie, last name Hog. We would see this information. We're still getting all of the columns because we asked for all of the columns. If we didn't want the ID field, then we could do something very similar. I'm going to just get rid of that and then change the star from actually a particular to a particular set of columns. And so we can label them by name here, and I can write select, not all of the columns, ID is kind of irritating. I want to select the first name, and the last name, from customer. There should be a space there, running out of room. Okay, select first name, last name from customer, where the ID is equal to 2. And that would return just this information. All right, but a lot of the time someone would come up to you and say, hey, I want to know information about my cat. Okay, well, what information do we have in the table? We have ID, first name, last name. Oh, I know his first name. So I could say, okay, well, give me all the information about your cat. His name is Willie. So I could say select first name, last name, or star, doesn't really matter. Whatever columns you want to see, select that information where the first name is equal to, put in quotes because it's a string value, or letters. First name is equal to Willie. Okay, and what that would do is the exact same thing. We're going to get this information, except we use some sort of logical identifier to actually get that value. And in real life, that's what's going to come up a lot, is you have to do these combinations of like this value equals this, or this value like this. And so, for example, I actually said this on purpose at the beginning. Say, I don't even know how his name is spelled. Okay, I know it starts with a will, and so what I can write instead of this equals idea, that's a little restrictive to have it exactly the same. So I could actually do where first name is like, this is a keyword, is like, it's like will, all right, and then %. And what this does is it's going to make this equal when the first name starts with WIL, and that this capital actually did matter, I believe. And the % is just a way of saying, 0 or more characters after this, or it's just like it starts with will is the easiest way to explain how this is working. All right, so now we've gotten specific information in a couple different ways. Now let's actually try and do something numerical. And to do that, I'm going to make another table. All right, I'm going to put it right beside this table. And so again, I'm not suggesting that I'm actually writing SQL to make the table. I'm just showing you that there actually is another table in the database already. We're going to have this orders table. Okay. So it's going to represent information about customer orders. Note that in your mind, you're likely already thinking the information in these two tables is probably going to be linked because one's about customers, the other's about customers making orders. And so there's going to be some information that's going to be the same here. That's the whole idea of the relational design. Okay, so again, I'm just going to have an ID field. It makes it easy. I'm also going to have an item ID. Okay. And so you could probably guess that in another table, I might have some information on items, and that would give maybe the category, the color, the brand, and so on. And so for right now, I'm just saying that this is referring to some particular item. Whenever I have an ID in this item ID column, it's referring to some particular item. And how do you choose to represent that, or how the creator of the database or maintainer of the database chose to actually represent that is up to them. Okay, so those are two columns. You have some order ID, you have some item ID, and you have some, say, price. So that's what price the item happened to be when it was bought. And so when, well, we could probably have a date. Okay, so time. And since it's in an orders table, we're going to assume that just refers to time of purchase. In an actual database, there'd probably be a few different times. It'd be like time of purchase, time of processing the order, time of shipping the order, and so on. But for now, we're just going to say it's going to have some time. So I'm going to actually add one more column here, and we're going to add in a customer ID. Okay, so our final thing here is who bought this? And notice I'm not putting a first name or a last name because we have that information in the customer table. We can look that up as long as we have this ID field. And that's why we use these IDs, is because when we're referring to these other columns, you can almost always do it just by an ID, or maybe an ID and a time combo. So then to fill in this table, maybe we had, okay, ID 1, the ID for the table is just going to start at 1 or something like that, some simple number. And then what item ID was bought? Well, let's say that item ID 4 was bought, and the price was, say, $10. The time it was like 0429. And now that this is going to be confusing because if anyone's seen a time or a date column, they'll probably think something like, oh, it's actually the day, month, year, or month, day, year, and year, day, month, and year, month, day, and timestamp, or just timestamp. There's so many different combinations of dates, even across different tables in the same database. It can get really confusing. I'm going to use something simple for now, where the syntax is going to be basically the same. And when you go to use your actual SQL, then you can go to look what the timestamp is and what you actually have to use. Okay, and now customer ID. Who bought this? Say that, well, customer 2 bought this. All right, and yes, that does refer to this column right here. The customer ID, whoever bought this, it's referring to this column. Okay, so I'm going to color this so that you know that there's a relationship here. Relationship, it's relational design. These tables are related to each other. The ID column in this field is relating to the other one. So whenever you see it, whenever you see some value like this, it means it's referring to this same information. Okay, that's pretty much the whole relational design at this point now, is that we have relationships between these tables. Here is one, and it's going to be very, very useful later. So to fill in a couple more values here, maybe we had an ID of 2, and actually I guess I was drawing rows for the other one. So row like this, item ID maybe 2, price was say $5, time was say 0125, customer ID was say me. Okay, let's do just 2 more quickly. 3, 1, 5, 02, 07, 2. And actually, you know what? That's fine for now. So we'll just leave the last one blank. Okay, so we have 3 rows in our orders table, 3 unique different orders where the item 4 was bought and the price was 10, the date was April 29th, and who bought it, customer ID 2 was. Or if we look later, we could see that it was Willie, but from this table, we don't have that information, but we can get it. So the second row, ID 2, we have the second ID, or second item was bought with a price of 5 on January 25th, and the customer was customer ID 1, which again, we could look to see that was Greg Hogg, but we can't actually do that without looking until later. And the third and final order was item ID 1, which had a price of 5, and it was bought on February 7th, and the customer who bought that was again customer 2. Okay, so let's do some numerical information on actually just this table. So I'm going to just pull this table into the frame. So back to SQL, we have some actual numbers now. We had technically ID fields before, but that doesn't really count as numerical values, even though they might be integers internally. But here we have, say, a price. Okay, something simple you might do at the beginning is just to select star from orders. Okay, and that would actually return you this information because again, you couldn't actually see it until I showed it to you. So now we see all this information, we have a feel for what's going on, and now I wanted to do some price calculations for fun. So let's compute an average. Okay, so to do an average in SQL, you would use the very cleverly named function called avg, or avg. So you do select, and now this is tricky. This is kind of confusing to some people because in this next piece, you write what the columns are. You say, what columns do I want to see? Okay, well, you can actually kind of make your own columns. And this column that I want to see is average price. Okay, I want to select the average price. From what? From orders. Okay, and the information that would show up now is we would basically see average price, and it would calculate the average for us. So amongst all of the rows, we would have 10 plus 5 plus 5 is 20, divided by the number, which is 3, and so that's going to be, what, around 7, 6 and a third or whatever. So let's just say approximately 7. Okay, it's just the average of the price. Very similarly, some other very common ones that come up, and believe me, these aren't even contrived examples that seem like something you would never do. I write stuff like this every single day. No more complicated than this, other than with a different table name and a different column name. So we do select maybe the minimum price from orders. And what that would do, as you could probably guess, was instead of an average price, we would have a minimum price, and it would be not equal to 7, or not approximately equal to 7. It would actually be exactly 5. Okay, and similarly, there's max. There's also something called count. If you put count price, then that would actually deliver 3, because there's 3, the number of rows. And there's some other ones that you can feel free to look up on your own if those ever come up. These ones come up very, very commonly: minimum, average, maximum. I'm sure there's some sort of median that might come up fairly often as well. Okay, so that's the idea behind this, what we call aggregation, which is just kind of getting a bunch of data and then performing some numerical function on the data. So like a minimum, an average, a maximum, a count of how many there are, and so on. Now this is great, except all that we've done is just compute these aggregations on the entire table. What we can actually do is group this information, okay? And we'll see that there's potentially common groups that come up within the data. For example, we have duplicate values, not duplicate rows, as in we don't have exactly the same rows, but we do have duplicate columns. Okay, so look at these 3 things. We have 2 natural groups that show up, and I'll circle them for you right here and cover them. So we have this one group, the green group, which is where the customer IDs are 2. They're all referring to the same customer. Each of these rows are referring to the same person. So that's a pretty obvious group. It sounds weird when you say group, but they're referring to the same thing. That's what we mean by a group. And this is referring to the same thing. Okay? So we have a green group and a blue group, where each of the groups are some particular customer in this example. Okay, so if we wanted to compute, say, the average price for each customer, then we can do that by grouping, and we just have to specify the group. So we'd select, say, the average. I'll go back to the average. Select the average price from orders, and then I would write group by. I would write group by the customer ID. Okay, and then what SQL knows to do is say, oh, okay, you mean everywhere where the customer ID values are the same, then we'll treat those as one particular group. And so when we select the average price and group that, it means we want multiple averages. We want one average per group. So what we'd actually produce at the bottom is we would have, and actually this doesn't really make sense unless you do unless you specify that you want to see another column. You want to select customer ID and the, average price. So we want to see the customer ID along with their average, because otherwise we wouldn't know who to assign the average to. So this would produce at the bottom, we would have customer ID, and we would also have the average price, Okay, so we'd have each of these groups in here. So for group 2, we would have an average price of, we'd look at 10 and 5, we get 15, divide by 2, so the average for that group is 7.5. So that's one average. And then we'd have another average for group 1. And so the only information for him is this price, and that's 5. So for customer 1, we have an average price of 5. So we have these two different groups in this example, and an aggregation per group. All right. Now the only other thing we'd want to do in our example is just to sort the data. And so that means, what order do you want to present the information in? Well, I actually want to show you the prices going up first. So in ascending order of price. So that means the lowest price would be first, the second lowest price would be second, and so on. To do that, I would select these things from customer, group by the customer ID, and then I would actually sort by, what do you want to sort by? I want to sort by the average price, okay, and then if I want to do it in an ascending manner, then I'm going to write something like ascending. Let's go with ask. Again, this type of thing is different per SQL, and you can just look up which one works for you. In an agnostic way, this makes sense to sort by. It'll be sort by every time, and then the column, and then say ascending. And then what I would actually do is, I'm not going to write it out, but you would have this data, except it would be basically, this row would be flipped with this one. So all of this information would be up here, and all of this information would be down here, so that we had 1.5 and then 7.5. Okay, and now for one table, that is almost everything that you'd want to do. And if you need to do something else, you can look that up. Over here, we are looking at, say, their name. Okay, so if we were curious about maybe Willie's name, then we could look up Willie's information. If we didn't know his actual name, we could use like with wildcards to get that information. If we knew his ID, we could look it up by ID or whatever other column we happen to have. And then here, we did some actual numerical results. We had price, and so we could compute averages on the whole thing without specifying anything, any groups. We just meant do like an average of everything, and that's very common, or a minimum or a maximum of everything. But then oftentimes you have this natural groups that form. You have these duplicate values, such as the customer ID field. This is about an orders table that's tracking customer orders. So it shouldn't be surprising that we're going to have multiple rows with the same customer. And in this example, customer 2, which, happened to be Willie, he bought 2 things. And customer 1, Greg, he bought 1 thing. Okay. Now, we can group those things, perform an aggregation on those results, and then we can see a grouped average, or the average price, for example, for each customer. And we can sort that data in whatever order we want to see it. This is everything, very close to everything you'd want to do with one table. Okay. Now, there's a reason I drew these 2 tables side by side and have the information linked together through this arrow. Okay. There is a very obvious relationship between these 2 tables. Now, I'm just going to take a moment to kind of refresh my database because I got some weird colors here, so give me a moment for that. Okay, So that was probably confusing, but believe me, I have the same thing, so I just cleaned it up a little bit. So we have these two tables. We have a customer table, which has information just about customers associated with their ID to uniquely identify one. And we have an orders table, which has information about orders, and also it has this column that has the customer ID, which means these two tables have similar information. When I see a twos in here, it's referring to this two. And so it's referring to this piece of information here. And when I have this blue thing, this one, it's really referring to this information. Okay, so we can do what's called a join, which means we want to basically join these tables. We want to do it on some column, or on these two columns where they equal. We need to tell SQL that this relationship exists. And we'll do that in the most basic query possible, which is with a, let's write select. So I will select star. So all of the columns from, say, orders, join with what table? I want to join it with the customer table. So join it with customer on. So this is referring to these columns, okay? So we need to tell it the relationship that exists. And the relationship is that the customer ID column in the orders table is referring to the ID field in the customer table. And so what we'll do is on the customer dot ID, where that's equal to, that's an equals, is equal to the orders dot customer ID. Okay, and this query is just fine as is. So if we select all of the columns from the orders table, join that with the customers table, wherever the customer ID is equal to the orders customer ID. And so I'll show you the result that is produced, which is absolutely beautiful, and almost the entirety of the relational database design is so that you can do this very thing. So we would have some table, and it's all going to be one table. I'm just color coding to show you where each columns are coming from. We would have an ID, and we would only get the rows that match with the other table because we did a join, and so we have an ID of 2 and 2 and 1. Okay, that came from over here. The only matches that we had, well, we looked at basically in the orders table, we had 2, 1, 2. These are our not even different values, they're not distinct. These are all the values in the table for the customer columns. Okay, so all of the ones that we had with customer were, we had 1, 2, 3, 4. So what we do is for each of these, or equivalently each of the other ones, doesn't really matter how you do it, it's going to return or merge the information with every match here. So this 2 or this 2 is going to get merged with this 2. And we look at all the matches, it doesn't get anything there, okay? And then we look at this 1. So this 1 is actually going to get merged with this 1, okay? This 1 is actually going to get merged with this 1. And this 2 is going to find the same matches as the other one. It's going to have that 2. So we had 3 matches. We had a 2, we had a 1, and a 2 match. The first 2 in this matched with the 2 in the other one. The 1 matched with the other 1, and again the 2 matched with the other 1. So we're going to have 3 different rows, and the order of this data doesn't really mean anything right now. How it's ordered is kind of random. But we would have information that looks like this. we would have this ID column, and actually it depends what database you're using, but sometimes it might actually duplicate this customer ID column, and in this table with this join you'd have to have these values as exactly the same, otherwise our join must have messed up, because the whole point was we're combining these information based off of the IDs being the same. So we'd have customer ID here as well, and we would have to have the same matches. We would have to have 2, 2, and 1. If these didn't match, this would make no sense. Okay, and then since we asked for all the columns, we would actually have all of the other columns, and we would have the ones coming from the customer table, like F name and L name. And we would have the orders information as well. We would have the item ID, we would have the price, the time, and we already did the customer ID, so we're not going to do that. Okay, so let's just draw our axes to make it clear. All right. Okay, so now let's fill in the data in this table. And so what we did was match up all of the rows. So I will show again, we matched this row with this row. And so that'll be the first row where we have all of the information of those two tables merged together on that specific row. So just to draw what that means, it's a little tough until you see it. It'll have these two ID fields being the same, and they're referring to Willie, Hog, and the item ID will be from the first row in the orders table. It will be 4, the price was 10, the time was 0429. Okay, so that was our first match where we looked at the first row of the orders table, looked at its customer ID, which was 2, and we found all the corresponding matches in the customer table, which was just the second row, which had Willie. Now, if we look at the second row of the orders table, we have a customer ID of 1. We now put in all of the corresponding matches with the customer table, and so that there's only one corresponding match again, which is the customer me, really. It's Greg Hogg. And so, actually, sorry, I'm doing the bottom row right now of our table. So to fill that in, where our customer IDs are 1, we would have my name, and the order ID is coming from the second row of the orders table, and that would be item 2, the price was 5, and the time was 0125. All right, that was the second row of the orders table, found all of its matches. It was only one match, and we put in that information. Now let's do it. The final row of the orders table, our customer ID is 2. We find all of the corresponding matches in the customer table, which is just Willie, and so we add in Willie, Hog, and the order information is from the third row in the orders table, and so that would be item 1 was bought with a price of 5, and the time was 0207. So just to study our specific SQL query in depth a little bit more, note that I pretty much just kind of glossed over this whole dot notation. The reason I had to do this when I was referring to a column was because we're actually, in our query, we're including multiple columns, and so we have to specify the table name and then dot notation, the column name. Technically, you don't have to if in the two tables you don't have the same column name. As long as there's one column it would know to refer to from a given name, then you wouldn't have to. But often I just do it because then you don't really have to worry about that being an error. So I'm going to restructure our query so that we see basically all the information we would actually care about, which I think would be and I mean, that's up to whatever query you want. I'm going to say that I only want the names, the price, the ID, or the item ID, and the time that they bought it. Okay? So I don't care about the IDs of the customer, is basically what I just said. Also, I'm going to write it a little bit better, and I'll show you what I mean. So, some modifications. Select star. I don't want to select star. I want to select some particular columns. I want to select, I need lots of room here. I want to select the first name and last name, except to do that, I'm actually going to use what's called an alias, because I would have to write customer.firstname, customer.lastname, but I don't actually want to write customer every time. If I write join customer as C, okay, join customer as C, that means anywhere in this query, when I refer to C, I'm really referring to the word customer. That's called, it's an alias, it's just a different name for the same thing. And I could write in here as well, I want to refer to orders as O. Okay, so if I write before this join, if I write orders as O, that's saying whenever I mean O, I really mean orders, and whenever I mean C, I really mean customer. So now I can actually select this a lot easier. I can select C dot first name, that's referring to customer first name, C dot first name, C dot last name. Okay, what else do I want? I want some of the order information. I want the item ID, I want the price, and I want the time. And if I was to write an actual query, there would probably be an items table, and I would end up joining with the items information as well to actually see, say, the name of the item and the category of the item and so on. But I'm not going to bring a third table into it, but that's why I included that column, is to show you would probably do another join there as well. So I have C dot first name, C dot last name. I have O dot item ID, O dot price, and O dot time. Okay, and there'd also be there'd be a from here as well. Okay, so sorry about it being kind of jumbled up. I ran out of room, but I have select C dot first name, C dot last name, O dot item ID, O dot price, O dot time, from orders as O, join with customer as C, and then do that same join that we did before. And actually, if we wanted to, we don't have to, but since we bothered to do the alias, we could actually just fix it up and write C dot ID is equal to the O dot customer ID. Okay, that's the query I'd actually write. I would write select C dot first name, C dot last name, O dot item ID, O dot price, O dot time, from orders as O, join customer as C, on the C dot ID is equal to the O dot customer ID. And that would produce exactly the same thing, except I wouldn't see this stuff. Depending on what database you're using, you might even not see it anyway, or maybe you'd see one of them, maybe you'd see both of them. I've seen all three of those things. And so we'd be left with this information, which is the joined information. Since the customer was referring to this same thing in both tables, we joined the information, and we did that using what's actually called an inner join. It just means that we returned all of the information that where the matches happened. Instead, there's actually other joins where since there was actually mismatches, like we tried to match this this 2 with, this 1, that didn't work, that was a mismatch. It matched with the 2, it didn't match with the 3, matched with the 4. There's actually some other types of joins you could look into, like left and right joins, outer joins, that would kind of have different behavior there. But for our example, and the by far most useful join, in my opinion, is just inner join, and that's why it's just called join. Like, we only note it's called an inner join, but I only had to write join because that's probably the most popular one. But I'm just telling you they exist. I'm not going to talk about them. That is something that may come up in the future. So this was under an hour as planned. I sincerely hope that in this hour you learned 99% of the SQL you would need to do the job. I'm not going to pretend this is 100%. It will give you pretty much everything you need to know to actually get the data that you want. So this was the first step. It was pulling your data from, well, it's on basically a hard drive somewhere. It's on a bunch of different hard drives in this database format. We need to get what we want. We need to use this SQL to pull the data that we want, maybe perform some aggregations in groups to get what we want, and now we have it in main memory. So as a data scientist, we would actually we would have this data pulled into RAM, or main memory. We would use like a programming language on it. Maybe some people would use Excel. I personally would use Python to do all of my work. It doesn't matter. The point is that to get the data, you need to use SQL. We just did that, and now the next step is to actually do something with it now that we have it in main memory. And if you don't have it in main memory yet, maybe what you actually did was you saved this to like a CSV. And so you got your data into a table that you are happy with. So maybe that's you pulled that into main memory already. Maybe you saved it to a CSV and you can easily pull that into main memory. But here's the point, is that our data was on a hard drive in various different tables. We need to pull it into a format that we like, which is just one table. As data scientists, we really want all of our information to be in one table. In reality, they're not. They are in various tables. You have to do talk to people to figure out what information is where, and do some SQL to actually pull it into one table. But you can get it into this one table, all of the information that you want. And now we're going to assume that you have that information. In the next video, I'm going to show you how to pull this data from a CSV. So I'm going to assume that basically we had done a bunch of SQL and saved our information to a CSV. That lecture is going to be about manipulating that data in Python and Pandas and Matplotlib to graph it, and to actually show you what's going on with that data that we are now pretty happy with. Okay, so thank you so much for listening. If you liked the video, please like the video. Please subscribe to the channel. As I said in the warning at the beginning, 75% of the people that watch these videos aren't subscribed to the channel. I would really like to change that and ring the bell to know that whenever I send out a video, you will be notified right away. So thank you so much. Please leave a like and a subscribe. I'll see you in the next video where we talk about Python. Bye-bye.